Hey guys, today we'll be talking about a different kind of a force, which is, let's say, in its simplest terms, known as the turning force. Now, initially or previously, we have seen whenever a force acts, let's say, on a mass m, let's say this is the force that is acting on this mass, it drives a mass to some distance. Let's say this is 10 meters of distance. It takes a mass 10 meters away. Just assume the situation here. Or let's say there is another, this is let's say case 1 and this is case number 2. And what happens here is that, let's say this is a mass here and it is acted upon by the gravitational force here. And let's say it's falling from a building here. When it's falling, it covers a distance and eventually comes and falls to the ground and covers a distance of, let's say, 20 meters here because of this action, or the action of this force, the gravitational force. So all of this change in distance because of the force is known as the translation effect of a force. And we say that the mass has translated from one point to the other. So the forces that we have earlier seen are known as translation force. But now we will be talking about the turning force, because we know that forces can not only translate an object, they can also change its shape, its direction, and also make it move in a particular direction, or turn it, as we say in its simplest form. So let's talk about the turning force, or turning effect of a force. Let's take a case here, or let me just change the color. Let's say this is a doorknob here. This is door here. Now let's say this is a doorknob here. So what happens is, let's say I'm trying to open this door. So from our earlier analysis, what we do is we have our hand here and we push it downwards. So actually what we're doing is we're applying a force downwards in this direction. However, what happens exactly is that this doorknob moves in a circular arc and, let's say, comes to its final position like this when we apply this force. If you would say, for a translation effect, if I would simply apply the force on the same doorknob and you want to see the translation effect, if I apply a force downwards, what would happen is this knob would move and come to this position. So this is the translation effect. However, in this case, it has not translated, it's fixed here in its original position, it's fixed, but it has turned a bit. In this case, the force is turning a mass or an object. Here it becomes a turning force, and this turning effect of a force, turning effect, is also called moment of a force, or torque of a force. Now, what is the numerical meaning of moment? Basically, moment of a force, moment depends on two things. first of all, the magnitude of force applied and the distance of the force applied from the pivot. Now, first of all, I would like to clear some concepts here. We'll do the numericals in the next video, but let's just clear some concepts here. First of all, I'm talking about the direction of movement here. Now, you'll have to imagine some things here. Let's say this is a plank and it's fixed here, it's supported by something, or I'm just holding it from here. Let's say I'm holding it from here. And one of my friends, he just comes here and applies a force in this direction. What do you think will happen? Well, from our experiences, I can say that this plank or this ruler or whatever this thing is, it will move in this direction. Something like this. However, if I'm holding the plank from this side and I apply a force here, this plank will move in this direction. So there are two possible cases of movement of an object or turning of an object. This one you can see here, this is an anti-clockwise motion. What do you mean by anti-clockwise? Anti-clockwise is the reverse path of how a clock moves, and you know it moves like this. So this is the clockwise motion. And this is the anti-clockwise or the reverse path. This is called anti-clockwise motion. So this is the clockwise motion and this is the anti-clockwise motion. So first of all, you'll have to make sure that which direction this force is causing it to move. And we will see when we'll be doing the numericals that this will be very important. This direction of movements would be very important. Another concept that I want to clear here is regarding a pivot. A pivot is basically, in simple words, support or a fixed point. Let's see, if I have a ruler here, alright, and I am supporting it from here, and say I am holding it from here, or this is fixed, I am, let's say, I have a nail here, and this is fixed, it's not moving from here. So, if I apply a force here, this is my pivot. I can also apply a force here, and even in that case, this becomes my pivot. But remember, pivot is an arbitrary concept and it's not always fixed. You can take any point as your pivot, but that point should be standard in all your calculations. But you, whenever you take a pivot, you assume that that point is fixed and you are not moving it. So this is a pivot in this case. So when we talk about our numericals, when we discussed earlier, moment, which is a capital M, is given by force times displacement from pivot. What I meant here was that the magnitude of this force, let's say this is 20 newtons. The magnitude of this force times the displacement from the pivot, or to be more precise, I would say the perpendicular distance from the pivot, because this distance would always be perpendicular to the direction of the force, we would consider this distance from the pivot, this horizontal distance, because this is making a 90-degree angle with the force, and therefore this is the force and this is the distance, therefore these two are perpendicular. I hope you know what perpendicular is. So this distance is perpendicular, so I would simply multiply this force with this displacement here, and it would give me the moment of this force, the turning effect that this force has on this this block. And similarly, if I just multiply, let's say this is 10 newtons, and if I multiply this distance with this force with this distance, I would simply get the moment of this force. So remember, for now, you should remember, there are three things that you should remember. First of all, every force can cause a turning effect. All you need to change is the pivot, and every force can cause a turning effect. Also, secondly, that there are two directions, one of which is the anti-clockwise direction, the other is the clockwise direction, and these directions would be of vital importance, and you'll see this in the next video. And the third thing is that a moment of a force is given by the magnitude of that force times the displacement, which is the perpendicular distance from the pivot. Perpendicular distance from pivot. So these are the three basic things that you need to understand for this video, and we'll be moving on with the next videos, and we'll be talking about more concepts in the next videos. So stay tuned to it, and thanks for watching.